Pre-Cal 12s? Coach Jay, we're in first period today. Hope you're having a Gucci day today. The sun is shining, beautiful weather outside. Not that you care, but here we go. There's 6 cofunction identities. We recognize, though, that if I said find the sine of 90 minus theta, you recognize that we really are finding cosine. Y'all follow me on that?
Yes.
All right? So I say this, I'm just hitting it. I don't need you to memorize them. It'll be on your sheet. Just know how to apply it. I think the one that we had today that I was talking to a couple people on was the secant of 90 minus theta. That, again, is equal to cosecant of theta, which would then, if I gave these two, would be equal to what? What would this be equal to then? Good, Caitlin. It's literally that simple. Got me? Because if that's cosecant of theta, then this, that's my answer. Square root of 13 over 2. Okay? Y'all follow me on that?
Why is that equal to?
Yeah, good question. So if I took, let's talk about sine, because I think that's easier. If I said let me do this. Let me go backwards. Let me go here. Let me see if I got a unit circle on this. Here we are. This is the easiest thing because y'all know this. But if I took the sine of 30, okay? All right? And I took that identity and said, what is the sine of 90 minus 30? Well, first of all, the sine of 30 is 1/2, right? Okay?
Yes.
Very good. And sine of 90 minus 30 would be? Sine of 60, got me, which would be square root of 3 over 2, right? And this is equal to what based on that definition? Wasn't it cosine of theta? Like based on, like that's the definition, right? So sine of 90 minus theta is equal to cosine of theta. And what was theta again? It was 30, right? So we would say, what is the cosine of 30? Radical 3 over 2. I'm just showing you that this matches up here. Okay? So anytime I take a 90 minus whatever angle, that the sine of that whatever 90 minus the angle is the same as the cosine of that 30 as well. Okay? You don't need to know that. If that was just me and Caitlin, that's fine. Okay? But I just want to make sure. Kind of need that one from there. All right, questions there? Cool beans. Let's go to 4.4. And this right here is kind of our last thing before we go into the review process next week. We might have a little bit left over, but overall, this will be our last thing here. So let's get started. Let's get it rolling. All right, this idea of number 1, we talked about this point. Now, 12 negative 5, it's not. But if 12 negative 5 was on the unit circle, what would I do in order to find sine? What would be sine? I heard it. Negative 5. Good, Rosemary. And the cosine would be 12, right? Tangent would be y over x and go from there. The problem is does that say that now? The answer is no. Okay? Y'all see that? This is not on the unit circle because it doesn't say it. So we can't assume it. So when we go to actually attack this, we're going to create a little triangle right in there. All right? Just like so. So how far to the right does it go from the origin? 12. Good. Okay? How far, what is this side? Negative 5. Good. Okay, and what do I need to do to find the third side? Pythagoras, right? My son's name. So Pythagoras would be what we would go after, right? So 12 squared. That's really, sorry. Start there. So that. 12 squared. That's a bad one too. Sorry. Let's try this one. 12. There we go. 12 squared plus negative 5 squared equals c squared. What did you get when you did that there? What would be c? Good, David. Yeah, that's right. So we have 144 plus 25 equals c squared. 169 equals c squared, and therefore 13 equals c. So 13 is called my what? Hypotenuse. Very good. That'd be a cool name too. Cool name. All right, so we got 13 there. How do I find my trig ratios now? SOHCAHTOA. Yeah, good, Caitlin. So what would be the sine of this now? By the way, what is the angle always attached to? The origin. You said that. Annie, you're right. Yeah, it's the origin. So this right here would be the angle, okay? And then the triangle's always attached where? That's Good question, Coach. Good question. Yeah, the x-axis, and I saw Bianca do it too. I'm going to give that. I saw Bianca. Wow. Take it away, Jack. Take it away.
I think we'll win.
Is that what team are you?
I forgot.
I forgot. But his team's winning.
Yeah.
His team gonna win. Okay, so that's how we would attack it. Here's what I need you to know, though. Okay, when we go through this, you are just simply doing what we did earlier in the 6 trig ratios, right? That's all we're doing. The big thing is just setting it up. If I can get you to set it up, that's really the big thing, and then we attack it and go from there. Again, different. If I say it's on the unit circle, y is sine cosines x, right? Can anyone explain to me why I can just do sine? Okay, let me backtrack here. If I went here, why when I say that this point's on the unit circle, can I say that the sine is only 1/2? I will give you 3 tickets if you can explain that to me.
Because it's just one single unit, so it's that over one.
So yeah, keep going with that, Katie. I like this thought here. So if I created a triangle here, right? Same triangle like I did before. This is theta. Remember, it's connected to the x-axis. Here's this triangle. Boom, boom, boom. This opposite side right up here is 1/2, right? This is negative square root of 3 over 2. Why is the sine then 1/2 again? Just
Because the hypotenuse would just be 1.
bingo. Because when we think of a unit circle, great job, good work. When we think of a unit circle, the radius is what? 1. So in essence, we are doing that. We just don't show it because anything over 1 is itself. Okay? Y'all follow me on that? Cool, cool. All right. We are Gucci. We are Gucci. Okay. This right here, I like these. These are ones that a lot of people struggle with. I'm going to blow this up just a little bit so you can see it. I'm going to erase this. Hopefully you can see this part here. We're going to look and see what quadrant do these lie in, okay? And I need your help. So sine of theta is less than 0 and cosine of theta is less than 0. Anyone want to be vulnerable enough to say, I know what quadrant's in? Devin.
It's in the third quadrant
Because they're both negative?
because they're both less than 0.
That's pretty good. All right, so let's check this out. What's the across? Sorry, excuse me. There we go. How do I know what cross stick do we use?
All short teachers care. All students take calculus.
That's better. Yes, absolutely. A lot more dramatic than what I wanted to make it, but that'll work. Who said that? All students take calculus? You said what?
All short teachers care.
That's pretty good. That's pretty good. Right there. Now I'll get you. Good, Deb. Yeah, so when we look at it, we look and see where is sine and cosine negative, right? All right, so when we look at sine, that's the acrostic they use, David. David's confused right now. I'm sorry.
No, I thought like she came up with it on the fly. I was like, that's horrible.
It is horrible. But this is what people have been using, and it's a little disappointing. But we'll go with it. So where is sine negative? This is how I've always done it. Sine's negative where? Third and fourth, good. And Devin, you were exactly right. I was joking with you. But we know cosine's negative where? Second and third. Where do they overlap? Third. That's how we attack it. Okay. Someone else do. What about secant is greater than 0 and cotangent is less than 0? Someone want to come up and try to attack this here? You think it's in the second one? Annie does? Does anyone want to come up and show that? Come on, Annie. Let's do it. She's going to teach us. As she does this, the secant would be the same as what? Cosine, right? Cotangent would be the same as tangent. Perfect. Annie, show us the ways.
Sine is positive, so it's in this quadrant.
Nice.
And cosine is negative, so it has to be in one of these quadrants. So they both overlap in this quadrant.
Overlap there. Nicely done. Questions? Y'all get it? Rocking today. Good job, Jack. Nicely done. It's a ticket for enthusiasm right there. All right. Oh,
Sorry.
I'm not going there. Let's go to the next one. This one that we're going to do, by the way, this one is secant of theta is greater than 0. Cotangent is, I think we did that one, didn't we? We just did that one. What we're going to do here is we're going to take this one, and we're going to do the bottom one. This is where it gets a little tricky, okay? Gets a little tricky. I'm going to write this down over here. But what I'd like to do is just figure out what quadrant we're in first, and then we attack it using the triangle. Now again, half the battle of these is how do I set it up? If I can set it up appropriately, man, we're going to be good to go, okay? We're going to be G to G. So where is secant going to be negative and sine greater than 0? Okay, Caitlin? Yeah, why do you say that?
Because secant is the same as cosine. Cosine is negative in the second quadrant and sine is positive.
That's so cool.
So we have our acrostic, right? David, what's the acrostic?
All short teachers care.
Okay, I remember that. Me and David have a rivalry. That's why we're looking at that. Cosine is negative, right? Cosine is negative here and here. They overlap on this side. Now, Caitlin, did I give you a ticket yet?
No.
I'm going to give you 2 if you can get this right. You ready? What do I do now in order to solve for my 6 trig ratios? It's all in the setup, right? We talked about how it's in the second quadrant. You were right.
Make a triangle.
What would I do, Caitlin, to be able to help us out with that?
We'd have to convert it to,
Cool. Got your one right here. Jack, go ahead.
Triangle.
All right, come on. Make a triangle. No? Come on.
I don't know what I'm doing, but I'll give it a try.
Jack's got it. So it's in the second quadrant, right? Where does the triangle always connect to?
Origin.
Origin in? X-axis. Good. Rockin'? Good?
Well, that's bad.
We'll take it. We'll take
no,
it.
I'll fix it.
Very nice. Very nice. Where's theta? Rockin'? Need to phone a friend?
No.
Okay.
Sure.
Yes? Phone a friend. Who knows?
Anybody else?
Caitlin, do you want to go back? Anybody else?
What's the question again?
That's me. So we set up a triangle. We know why it's in the second. Is everyone clear on that?
Yeah.
We're Gucci on that? So we set up the triangle. Now the question is what sides do we know based upon this over here? You got it, David?
I have it. Yeah, let me see.
Come on, David. What's the reciprocal of secant? Cosine, which would be what for this instance? Yeah, negative 1/2. Just be careful. Keep that sign, right? I know some of us, I've talked to a couple of us here. Just make sure to keep that sign. Something we just got to remember. So negative 1/2. And again, it's all in the setup. Once we set this up, I think we're good in finding the 6 trig functions. The question is now we have cosine of theta equals negative 1/2, something we remember. What would we do there?
Wait, no. Oh wait, it's greater than 0.
We wrong? Fuck, we're wrong.
Time out.
You know what's funny is you did it in a completely different way than I would have done it. But you're right. You could still get the answer. That's pretty impressive. It's pretty impressive, fellas.
5
I've got you one. Nicely done. Okay, nicely
This
done.
is positive though.
That one's gonna be negative
Yeah,
because it's
what
going
I
to the
say.
left.
Dude, that's what we both said, dude. Okay, get off me.
I said that's negative.
All right, hey, let's do this. Let's talk through it, okay? I want you to just look at this here. This is one way to do it, okay? This is one way. What they did was they said that cosine of theta is negative 1/2. You didn't see that. I got you. Some of you did. Cosine of theta is
Jump over me so
negative.
you can see the class.
Yeah, I did. Cosine of theta is negative 1/2, okay? Which means it's the x value. Now, what they did is they went straight to our unit circle. You saw that. You actually could do it either way, and they would be both right. Does anyone know of another way? It's not better. Both are the
You
same.
almost said better.
I did, but it's not
That's
true.
hurtful.
Okay, it's not true. What could I do with this?
You hate it.
Cosine of theta equals negative 1/2 to be able to set it up, Caitlin.
You would do like how you find the 6 trig functions. You do the one side is negative 1 and one is 2. And
Yeah.
then, like for the bottom.
Yeah, so this is adjacent over hypotenuse, right?
Yeah.
based on that. So what's my adjacent side?
-1.
-1. What's 2?
The hypotenuse.
Which would be?
Um,
It should be 2. Yeah, exactly. Because it's -1's my adjacent, 2's my hypotenuse, right? So set me up Pythagoras. What would we do? Nice, good, Audrey. And 2 to the 4th. What in the world? That was weird. 2 to the squared, yeah. And then what we would have is 1 plus x squared equals 4. And Audrey, what would that be for x? Square root of 3. Good. So you can kind of see that this x is going to be square roots of 3. You're going to get the same answers as the guys had there. As I have this part, again, this is theta. So as I look at this, what would sine of theta be? Square root of 3 over 2, which is what they had, right? What would be the cosine of theta? -1/2. Good. And what would the tangent of theta be? Someone said it over here, right? Tangent would be negative square root of 3, right? Because it'd be opposite over adjacent. And then tangent, or cotangent, cosecant, and secant, you could just flip it, okay? How does that feel? Y'all get the setup?
Our way is better.
Your way is definitely probably better, yeah. Here's the one thing I would say on this that you guys got to just be careful of, or just all of us. If this was not a value that was on the unit circle, could I then just say that that adjacent was -1/2? I couldn't, right? So just be careful on that. If it was some like negative square root of 5 over 4, at that point, that's where we have to know adjacent over hypotenuse, okay? Though what the guys did, that's absolutely fine since that was on the unit circle, okay? Does anyone have questions on that? That can be sticky, but I think y'all are getting it based on y'all's facial expressions there on this part. All right, here we go. I think we have one more problem that I really wanted to hit on. What time is it? We've got 11:37. We have 8 minutes, which I told you I will do the hot seat. So we're going to finish with this one. Cool?
Katie's birthday.
And Katie's birthday, that's right. Maybe Katie could be on the hot seat
What was the hot seat?
if you want to. It's up to you guys. All right, let's do this. 4x plus 3y. Here we go, okay? As I attack this one, again, a little bit different. Let's look and see what it says. It says the terminal side lies in the given line in the first quadrant. Now, what that means is if I have initial, then if I were to draw this terminal side, if it's in the first, we just need to know that it goes upward in that direction, okay? All right, so there's that. And again, make sure you read that because it's not always in the first. It says find the values of the 6 trig functions of theta by finding a point on the line. Well, what we have now, because we're trying to find the 6 trig functions, is we've got our 90-degree triangle, and this is theta. The question is how do I find my adjacent and opposite? That's the question. But what I've got to do is I've got to get this to where it's a line, or where I have a slope. So what could I do to
Minus
find
that 4x.
the slope other than Jack? Because I've called on you.
Converted into y.
Let's have someone else.
I know the answer.
Wait, can we finish?
I got you, Jack. Let's respect
Flipping my
the
wheels.
Let's do this, Jake. That's it. Yep. Good. So 3y equals -4x. Good. Keep going. And divide by 3. So y equals -4/3 x, right? Good. Jake, got a question for you. You may or may not know, this is kind of going out on a limb because we haven't taught this yet. How does this correspond to the triangle, maybe? Yeah, the rise over run, isn't it? Isn't it? And as I look at this, there's a problem with this. There's a problem. And I think it was because one of these should have been negative. This is my fault. This should be negative here because, can anyone tell me why, Caitlin?
Because -4 here would mean it would have to be in the second or fourth quadrant.
Good, because, and this is just the dotted line, what it would have been, it would have had to go like this. But because it's in the first, it would have to have a positive slope. Do you feel me on that? I think I remember that and I just forgot to put it in. So this would be positive when Jake did what he did and what Caitlin had said there is that it's got to be now in the first or fourth, okay? But it said it was in the first. So 4 ends up being my what? Opposite, adjacent, or hypotenuse? Go ahead, Bianca. Oh, did you? I thought you had a light bulb moment. Opposite, good, good. And Jack, what would the 3 be?
Jason.
Good work.
Jason.
Adjacent, exactly right. Because the opposite, right? When we think of rise over run, 4's my rise, 3's my run. So if I rise up, that means this would be 4, and this would be 3. Okay? And someone raise your hand. Tell me, what's the hypotenuse?
5.
Bianca. 5. Good work. Good work. I owe you one. I've got a couple people I owe. I'm going to come around. Okay? So this would end up being 5 when I do the Pythagorean theorem. And then afterwards, I'm guessing, finding the 6 trig functions. How do we feel on that once I have the setup?
Good.
Good. It's pretty much the same. My big thing today was just focusing on different styles of problems. How do I set it up? And then attacking it is exactly the same after the setup that's there. Okay? All right, so I need you to understand this. On Monday, when you come in, we're going to go over one small thing, and it's literally 2 slides, and then we're going to start the review process come Monday. On Tuesday night, I'm going to have a YouTube help session before the test, okay? That help session will be on YouTube. We'll have some fun there, and then we'll rock and roll, all right? All right, very good. I did say let's do the hot seat today. Katie, you don't have to do it today, unless you want to. Cool.
What's hot seat?
All right, so here's what we got. First period today. What we got?